arguing a point with you that you disagree with. I try to relate it back to simpler notions that I think you might agree with. And if I can show that from those simpler notions, I can build up a persuasive account that my thesis falls from that, then you're persuaded. And if I can't do it, you're not. And it all depends on my thinking. We can find common ground if we go down to simpler pieces that we might both agree about. So that seems to me the essential mechanism of justification. So mathematical, so now let's take it through some areas of knowledge. Mathematical justifications analyze not yet proven theorems. In fact, in Euclid, when he ends a proof, he always ends it quod est demonstrandum. That's what we were meant, or that's what we were trying to demonstrate. Was, hey, I've done it. I've done it. But this one's in the bank. So, and again, what do you do? So you have Pythagorean theorem. All you do is work up to it by building a pathway built on things that are obvious, simpler theorems that have already been proven, and then way down at the bottom, some key things like the parallel postulate, an axiom that is taken to be so obvious, or at least so fundamental to the truth of Euclidean geometry, that you don't have to prove it. It's your starting point. So again, it's that same movement from more complex and disputable things down to simpler things that are easier to take at face value, or that have already been proven by running through this process. All right, natural science justifications they're quite different. They derive from empirical hypotheses whose predicted measurements are matched by experimental measurements. In other words, the way science justifies its claims is it comes up with a theory, and this part I suppose is imagination. That's the outside the box part of it. But then you devise an experiment. Well, first you develop the theory, and then the theory in a certain circumstance would produce this observable result, this quantifiable measurement. So now the trick becomes, if the theory makes that kind of prediction, if you can engineer a situation called an experiment where that very measurement is put to the test, then you simply, it's simple correspondence truth test. You match the prediction of the theory to the empirical result, and if they match, you're good. If they don't, you've just refuted the claim. Now, that's a standard that human-sized justifications can seldom live up to. They can seldom produce reliably predictable measurements for individual subjects. Subjects, they're people like you, they're ornery, they want to do things their own way. You can't get 100 of them all to do the same thing, like start writing the paper 2 weeks before it's due. Yeah. I have to show you, there's a great cartoon about procrastination that uses the F-bomb in describing the whole process of, I will see if I can discreetly post that, all right? So since individual human subjects aren't predictable, they're not automatic, and for whatever variety of reasons, either because they have something like free will or choice, or because there's such incredibly complicated wind-up toys that no one can keep track of all the variables. It almost doesn't matter. In either case, you get the same result. You cannot reliably predict the actions of individuals. So what human scientists mostly do is deal with them in aggregates. You do statistical studies of populations of individuals, and there you can begin to get semi-consistent results. They're never like 100% do it and 100% and 0 don't. It's, a good result would be, more than the margin of error. If 63% do and 37% don't, that's a damn good result. Okay, so such studies typically do not yield binary yes or no results, but middling percentages or spreads like a bell curve, or a bunch of them are in the middle and it tapers off to trailing, minorities at either end of the curve. All right. You know, the way to talk about human science is some subjects do, some don't. That's what most human sciences give you. So that's why you have to take refuge in statistics, because statistics gets around with the problem that individuals are ornery and unpredictable. Now, I want, in my printed remarks, which are going to be posted somewhere, where's that going to be, on Mashback or something?
Microsoft Teams.
Teams! Oh, yeah. Okay. IB's new love interest, Teams. Okay. What happened to poor old Mashback? Who loves Mashback anymore? Okay. All right, good. So I want to make a general point here now that I have an appendix and I make a general point and apply it to both this Title IV and also Title V, which is that it's good to make these broad general characterizations, let's say, of natural science and of human science. And they're meaningful, but they're a little bit general. So you can use other sets of distinctions that break